Alright, so question 10. We have two bars, one's curved, one's straight, and we're supposed to find the electric field at the origin right here. The length R. You have charges Q for each of them. So first step is to find the electric field coming from both of these components and then add them together to find the field at the point. So starting with the arc, you have the integral of k times q over r squared. I represent that with this k right here. You have sine theta to represent y component, because if you look back at the problem, the x components are all symmetrical, so you don't need to worry about that. So then once you integrate, you also need to take in consideration this beta, which I assigned as q over pi, which is charge per arc length, because arc length is what we are integrating by. So you integrate sine theta, which turns out to be 2, you get negative 2k q over pi r squared. It's negative because it's a positive charge, so in the y direction it will be pointing downwards. So now we go to the bar. Bar you determine the same way as k q over r squared. It's a little more complicated because the y component is going to be r over square root of x squared plus r squared. Because when you look at each given fraction of the bar and its y component, it's going to be the sine of this angle. And the sine of this angle is given by the opposite over hypotenuse. And the hypotenuse is going to be x squared plus r squared. So r over square root of x squared plus r squared. And then your r squared is just a hypotenuse squared, so the square root goes away. And then you have lambda, which is the charge per length, which is q over 2r. This length is r because of symmetry. Once you simplify it, you get k times q over 2, 1 over x squared plus r squared to the 1/2. Using integration tables and all that, you get this, and it simplifies through various series of steps to 2 over r squared over, or 2 over r squared times square root of 2. So then you come over here, simplify it further because the 2's cancel. You get kq over r squared times square root of 2. So now that you have this, which is your bar's electric field, and this, which is your arc's electric field, you add them together down here. When you add them together, you can simplify pulling out the kq over r squared to get kq over r squared times 1 over square root of 2 minus 2 over pi, which is the answer.